Hi, it's Peter from Teach Me Maths. I'm going to have a look at some simplifying fractions here. I'm going to try and make the whole method a lot simpler. People do struggle with simplifying fractions, and it mainly links back to times tables knowledge. What I'm going to try and show you here is that even if you have some gaps in your times table knowledge, you can still do simplifying fractions, or at least most of them. And I'm going to give you some tips for managing when you're not that confident on all of your times tables, which applies to quite a lot of people. Let's just get started straight away, really. I thought about maybe doing this video and kind of making questions up and teaching the methods like that, but it's actually just easier to teach by having lots and lots of questions, okay? So rather than do this starting at question 1 and then 2 and then 3, I'm just going to really look at this page and show you really what jumps out to me when I look at each one. And on the right hand side, I'm going to kind of write down the key ones. So when I look at question 1, it jumps out at me that they're both in the 2 times tables. Okay, now some of you will be looking and thinking, well, it's in the 8 times tables, the 4 times tables. You're right, but it jumps out at me straight away that it's in the 2 times tables. And I would probably try to look at as many of these as possible where the 2 times tables just instantly jumps out. And there's quite a lot. It normally is. So I'm basically putting a 2 next to all the ones that I can spot that are 2 times tables. Now, you might think, oh, you missed this one out, Peter. The thing with that one, that's something else that's much more obvious jumps out at me, that they're both in the 10 times tables. So there you go. That's our first one that we've solved. Okay, I've basically divided the top and the bottom of the fraction by 10. It's not wrong to halve both of the numbers, but then you get 5 over 15, and then you've got to kind of think about what goes into those, and it can all be a little bit slow. Certainly if you see a number that ends in 0, or sorry, if you see both numbers end in 0, then just take the zeros off straight away. Okay, so that one's done, 1/3. If the other ones are not divisible by 2, we should really be thinking, well, what other sort of numbers are going to jump out at us? This is in the 3 times tables. This is in the 7 times tables. This is in the 5 times tables. This is in the 3s. This is in the 5s. This is in the 5s. This is in the 3s. This page is relatively simple, simplifying fractions, but what I wanted to illustrate is that there are key numbers that tend to come up in these. They tend to be the small numbers. You don't really need to be looking at these and spotting 12 times tables and things like that. It's not wrong to do that, but most people are very slow when they start thinking about their 12 times tables or their 8 times tables and that kind of thing. Really, I've picked all of the numbers that we kind of need to do these questions, okay? So let's actually go ahead and solve them now. I'm going to do the ones in blue because I've got the blue pen, okay? So this is the 7 times tables. There's no alternatives with this question. If you notice that there's a 7 in the fraction, 7's a prime number. The only number that goes into it is 7. It's the only possible number that we can use, okay? So if you've got a simplifying fractions question, it's got a 7 in it. It's just got to be the 7 times tables. Okay. When you look at question 3, by far the most common other number that you're going to use, other than 2, is the 3 times tables. So I just divide both of those by 3. Divide both of these by 3. There's another one here, isn't there? This is both 3s. Okay, and all of those questions are finished. So let's go to the red ones. Okay, 2 times tables. Now, as I say, question 1 is a really good example in that, yes, a lot of people are going to spot that it's the 8 times tables and divide it down, and that's absolutely fine. The problem is when I see people trying to tackle fractions with larger numbers in them, they're trying to spot the 8 times tables still, or the 12 times tables. And then particularly, certainly in the old QTS test, we had a time limit on our mental maths questions, and people just fell apart because they're trying to spot 8s and 12s, okay? The best thing to do is just to spot that it's 2s and halve both. And then keep a careful eye on it, and if it's still divisible by 2, you just keep going. And you just keep going until you can't go any further. So what I've done there is I've just kept halving the numbers and I end up with a half. Okay, now some people might look at that and think that that takes longer. In my experience, with most people, it doesn't. If you can spot that it's 2 times tables immediately, and you can start the question immediately, most people will actually get to a half quicker doing it this way. So if we just do a few of the other ones, this one you've got to use 2. Okay, this one you could use the 4 times tables here, but it's not too, doesn't take too long to just halve it twice. This one is only the 2 times tables. Now this is another interesting one. 12 over 24. It is the 12 times tables, but again, if you're just halving both, halve them again. Okay. Now the thing is when you get to here, okay, you do need to spot that it's now in the 3 times tables. Okay, that can be tricky when you're first doing it. You might get to something like 3 over 6 and think that you've finished. As I said earlier, use your 2s and then 3 is the most common next number that you're going to use. Let's keep going. This one's going to be 2 over 8, but they're both even still, so we end up with 1 over 4. Same really with this one. In fact, that's the same question. That's a bit weird. They've put the same question on the same sheet. That's not very good, is it? Okay, this isn't my sheet. I just Googled it quickly and grabbed this sheet off the internet. Okay, so this one, I halve the 6, halve the 12, and again, you really need to spot that that's now in the 3 times tables. Okay, so you see that some of these, although I'm starting to use 2s, it doesn't mean that I'll only use 2s. Okay, and as I say, most of the time it will be 3 will be the next one. Okay, so if we look at 6 over 18, again, halve both, and then it should jump out that it's 3 times tables. Okay, and then what have we got left? I think it is just 5 times tables. Now, 5 times tables should be easy to spot. If the number ends in either 5 or 0, you know that 5 is going to work. So this one, divide both by 5, we're finished. This one, divide both by 5, we're finished. This one, divide both by 5, and we're finished. And that's it. I just missed one down in the bottom right corner there, didn't I? In red. Let's just go back to red. 10 over 16, just halve both, and it's finished. Okay, so there's a sheet of relatively simple ones that have been done, and there was one with the 7 times tables, 3 or 4 with the 5 times tables, and then basically I used 2s and 3s for the rest of it. So let's move on and have a look at another sheet. Again, let's just go through the numbers. Okay, this is 2s. Okay, this is 7s. This is 3s. This is 2s, 3s, 3s, 2s, 2s, 3s, 5s, 2s, 3s, 3s, and 3s. So again, there are other possibilities here. Question 1, you could spot that it's 4 times tables. Okay, there's a few others. When you get bigger numbers, if you look at question 8, 42 over 64, these are the sort of questions that I see people trying to search for bigger numbers. Oh, is it the 8 times? Yeah, 8 goes into 64. And then they think, oh no, 8 doesn't go into 42. Then they pick another, oh, is it 12s? And certainly in the old QTS tests, they've run out of time in the mental maths to simplify this. Okay, try not to do that. Just look at them and spot that they're both even, and just halve them. Okay, so again, let's start tackling these. Okay, I halve this, and they both halve again. So this is finished. Okay, 7 times tables. Not quite so easy to spot that. That one's a 7 times tables, but 21. Well, see, 14 is an even number, so we might be thinking about 2s, but because the bottom number isn't even, we shouldn't even be thinking about 2s, okay? So 21 is 3 times 7, so it's got to be either 7s or 3s here, okay? So divide both by 7, and that's finished. Divide both of these by 3, that's finished. Divide both of these by 2. Now, that would be an unusual question in QTS because this doesn't simplify down to something particularly recognisable. As I say, this is just a simplifying fraction sheet that I've grabbed from the internet. Could be any old numbers, okay? But the best thing to do is just pick 2s and see where you're at. The reason I know that 9 over 17 doesn't go down any further is that 17 is a prime number. It doesn't appear anywhere in your times tables. There's no way that you can simplify it down. Carrying on, just using the numbers that I've picked. So question 6, this is the first one that's got quite big numbers in it. I'll just divide that down by 3. How did I spot that that's 3s? I mean, they're both in the 9 times tables. I would maybe encourage you that if you know your 9 times tables, that yes, you divide this down by 9s. The reason I would suggest it on this one is because 45 is kind of outside of your 3 times tables. Okay, we learn 3 times tables up to 36 because that's 3 times 12. And 45 is 3 times 15. So this, you can see, this is where it starts to become a bit trickier when the numbers are bigger. If we just write that one out again, if you were able to spot that they're both in the 9 times tables, then you'd go straight down to 4/5 straight away. In my example, I use 3, but then I would have to use 3 again. I would need to spot that 12 and 15 are both in the 3 times tables. There's no easy solutions really for things like 36/45. I have got a video on my YouTube channel that's explains about the 3 times table trick. To cut a long story short, if the digits add up to a number that's divisible by 3, then it must be divisible by 3. So in this example, 36, 3 plus 6 is 9, that's divisible by 3. 45 is 4 plus 5, which is 9, that's also divisible by 3. So you know it's divisible by 3. Tricky question though, okay? But most of these other ones are not particularly tricky if you keep it nice and simple and just use 2s and 3s. Okay, so question 8, another one with quite big numbers in. But if we instantly use 2s, okay, although it's still not an easy question, at least we've made the numbers smaller, and then those numbers are more likely to be within our times tables, okay? Now this one doesn't simplify any further. 21 can only really be written as 3 times 7, and neither 3 or 7 go into 32, so it can't be simplified any further. Okay, so question 9, divide both of these by 3 and it's finished. Question 10, divide both of these by 5 and it's finished. Divide both of these by 2, 3, 3. Again, this one seems to keep coming up. It ends up being a half because it's in the 3 times tables. Again, you could look at the original question. If you spot that the top number, or let's put it around the other way, if you spot that the bottom number is double the top number, then you know it's a half. Okay, so it depends whether you're very good at spotting that one number is twice the size of another number. Okay, and this one, again, you could use the 9 times tables here, but you could do 3 twice. It's all personal preference and it depends what your strengths are. If you've got very good times table knowledge and your 9s are good, then obviously just divide down by 9. If they're not so good, keep using these smaller numbers. 2s, 3s, 5s and 7s is the main ones that I've used on this page again. So let's jump to this page. So I would look at this and say it's 3s. These ones where they've kind of given the answer and we've got to work backwards and get this, I'm going to just skip those for now. I'll mention those in a minute. I'm just going to look at these main ones and spot the numbers. And as you see, I'm trying to do it super quickly. I'm trying to not overthink it and just try and get the right numbers as quickly as possible. There you go. Done. Okay, and what numbers are they again? 2s, 3s, 5s and 7s. Okay, so top one, 3 times tables, divide both by 3. Next one, 3 times tables. At 3s again, I put 3s, but again, some of you might have looked at it and said, well, it's in the 9 times tables. That's fine. If you quickly spotted it's 9 times tables, use it. It's great. Okay, and this one is 7/10. This one looks horrible, but one of the numbers ends in 5, one ends in 0. Not easy to divide down. You might have to kind of do like something like a little bus stop method. This isn't the sort of question that you would get a really strict time limit on, like 10 seconds or 20 seconds on, because that just wouldn't be fair. So 5s into 11 go, 2, 5s into 15 go. And you could use this, okay? It actually is 23/46. And then hopefully, again, you might be able to spot that the top number is half the size of the bottom number. So this does end up as a half. You could even maybe spot that at the beginning. Certainly for sort of QTS type skills, this isn't a sort of question that would come up. The numbers are just too big. They don't tend to test you on that. Or they didn't. I know things have changed, okay? So question 6, so why did I pick 7s quickly in there? Well, 49. 49 is 7 times 7 and it doesn't appear anywhere else in your times table, so it's kind of got to be 7s again, okay? This one simplifies to 2/9. This one is just an easy 5 times tables. Well, sorry, it's easy to spot that they're both divisible by 5. It's not easy to work out how many 5s go into 85. Again, bus stop kind of method does allow you to get these fairly quickly. 5s into 8 go 1, remainder 3, 5s into 35 go 7. Okay. Now, these other questions are kind of, I think, in my opinion, less important, but they are quite useful to kind of understand what's going on with fractions. So when you look at this, somebody has already divided this number down. And it should be obvious that that 1 is 3 times smaller than the 3. So the number that's here must be 3 times bigger than the 4. Okay, so it's really about looking at what's matching up. If I just do one more question, it'll make a little bit more sense. So if you look at question 11, we can see the bottom number in both fractions. And this has been divided by 9 because 9 times 5 is 45. So I times the top number by 9. Okay, and so on. And look, the trouble with these is they're starting to get bigger numbers. Look, I know that that's been divided down by 16. Divide the top number down by 16, you get 2/3. I don't think that's so helpful. I think what would be more helpful is if you were simplifying 32 over 48, is that you just were good at halving numbers. Halve the top number, halve the bottom number. Halve the top number, halve the bottom number, halve the top number, halve the bottom number, and you do it one more time, halve the top number, halve the bottom number, and that's 2/3. So that would be, a good way of simplifying that fraction without having to use large numbers. Okay, so when you start recapping this video and writing down, well, which times tables did Peter use the most, by far and away, it was things like 2s, 3s, 5s, few 7s, not many. The problem with 7s is there's no alternative. You can use 9s. 9s are useful but not essential. 12s are, in my opinion, are fairly pointless. I mean, if we're going to learn 12 times tables, you might as well carry on and learn 13s and 14s and 15s, etc. Okay, so hopefully that will help. It'll give you a few hints as to where to start when you're looking at some of these fractions. Okay, good luck, and let me know if there's a particular fraction that you find that you're having trouble simplifying. Okay, bye.